So we all know the biggest challenge every food processing industry faces these days is the lack of advancement and innovation in its manufacturing practices. To bridge this upgradation gap, we at Neologic Engineers decided to present an emerging food tech webinar series where we will talk about cost-effective food processing automation solutions and applications of top-notch machineries and technologies, then current trends and future directions in the food processing sector, and many more things. We have been conducting such webinars since last 3 years, and in this 15th webinar of this series today, we will be talking about latest process technologies in paneer freezing and cheese cooling, packed cheese cooling for extended shelf life. Today, on the panel, we have Mr. Sri Krishna Ozarkar, Business Head, Fruits and Vegetable Division and Spiral Solutions at Neologic Engineers. And we have both the directors, Mr. Ravindra Mahajan and Rajendra Bore, as a panelist. They will be moderating the webinar. Let me introduce you today's speaker, Mr. Sri Krishna Ozarkar. Born in middle-class family in Nashik, he completed his entire education in Pune by completing mechanical engineering from Pune University in 1987. After spending a few years in SKF, he joined Alpha Level and worked in project planning and execution in the dairy and beverage sector of the manufacturing department. He started his entrepreneurial journey by starting his own firm in 1996 and eventually merged his business areas with Neologic Engineers. Professionally, a hardcore technocrat, engineer, and valuer, his interests are reading books and listening to Indian classical music. So, ladies and gentlemen, let me present our speaker today, Mr. Sri Krishna Ozarkar. Over to you, sir.
Thank you, Nikhil, for the wonderful introduction. Good afternoon, all. Let's try to be interactive this time. So, as you can see, the topic today is the latest technologies in paneer freezing as well as the packed cheese cooling. And both are for the extended shelf life of the products. So in the session, what we are going to see, the objectives of the session. Let's try to understand the objectives of the session. First, for the paneer, we will be understanding what is paneer and the ways of extending shelf life. And what is the typical good way for paneer for extending the shelf life, that is IKF. And in cheese cooling session, that is the second part of the session, we are going to look after how the cheese cooling for the post-filling cheese needs to be carried out and how the spiral air cooler is going to be more effective in that particular aspect. So these are the two sessions which will be dividing the freezing and cooling part of the entire session. So paneer, we'll first start with the paneer and its shelf life and the need of the hour. As you can see, the paneer, everybody knows paneer. And paneer is a typically famous heat and acid coagulated, non-fermented, non-rendered, and non-melting soft cheese, very popular in India, Southeast Asia, and holds a strong demand between vegetarian and non-vegetarian consumers. It contributes to a major protein source for the vegetarian consumers due to its superiority in digestion, and as well as the high biological value. The water activity in the product, that is in paneer, limits its shelf life to say around 1 day at ambient temperature and say up to 6 to 7 days under 10 degrees of household refrigeration. So let's try to understand about paneer and its shelf life. We all know different dishes of paneer, and you can see one of them on the screen. So several attempts have been made to increase the shelf life of paneer, and some of them are in-can thermal sterilization, dipping in brine solutions, use of some of the acids, application of antioxidants, modified atmosphere packaging, getting very popular in last few years, UV treatment, individual quick freezing, which we are going to look in detail in coming slides, and blast freezing. So frankly, the old methods which we have been discussing, these have been a partial success. But the blast freezing as well as individual quick freezing have achieved more significant success. The old methods from various perspectives like efficiency, legal approach, or even statutory compliance are not really advisable. So we'll focus mainly on the instant quick freezing of the paneer. So here is one of the examples of direct freezing of some of the products, vegetarian products or some of the non-vegetarian products. Originally developed as a specific solution to block or cluster freezing of small size products and to preserve quality and give unparalleled convenience to end users. This method of IQF has a unique ability as it freezes all its components individually by keeping them separate from each other. This makes it easy individually to freeze and store products like peaches, berries, grapes, prawns, peas, fish, shrimp, cheese, and other poultry products. This particular technology freezes individually using fluidization technique. That is, product is suspended in higher velocity, which leads to freezing of the food products in about 10 to 12 minutes, which otherwise would have taken 3 to 4 hours. Thus, most of the properties of the parent food is preserved as the formation of big crystals does not take place, which damages the tissues of the food material. Moreover, it also prevents the advantage of saving energy and the time, as one does not have to thaw or defrost the entire whole packet to take out only a portion of the pieces. So the rest of the portion will remain frozen until further requirement. This is very good advantage. Another advantage of IQF technologies is also to have its ability to separate the units of products during freezing, which produces higher quality in comparison with block freezing. This is also important for sustainability, as the consumer can defrost and use the exact quantity of the food required. So these are typical some products available in the market. And we are very proud that Neologic is associated with these machines for the instant quick freezing of the paneer. So let's also try to understand what is the difference between frozen and IQF. Before I go further, let me also congratulate all of us, because today we have a record attendance from different countries, so different parts of India. And we also have people joining from Italy, people joining from Gulf areas, and some part of the Gulf African continent. Okay, so understanding the difference between frozen and IQF. The main difference here is the size and quantity of the frozen product. Cold store, which is freezing method used for large volumes or bigger size products, such as the whole chicken or packed meat. IQF, on the other hand, is ideal for freezing smaller products such as small fruits, fruit cubes, vegetables, cheeses or cheese cubes, pasta, and also the paneer cubes, which we are discussing presently. The mechanical IQF freezers work on the principle of cold air circulation, which flows from underneath, like we saw in the earlier slide, from underneath the bed plate or transport blade, with the help of the fans. The cold air flow passes through the pieces of product in circular motion while the product is also advancing through the freezer towards the exit. Here, the temperature of the air is typically between -18 to -34, and the velocities of the air are kept very high in the range of say 2 to 5 meters per second. This process is economical for producing many IQF products with variety of sizes and shapes as it can accommodate. So this is the main difference between the frozen product and IQF product. Now let's have some insights of the IQF. Like you can see, rapid freezing rates in commercial operations are achieved in IQF through an insulated tunnel with vigorous circulation of the cold air. Food commodities are passed through this tunnel on the trays or beds, where they are fluidized to form a bed of particles. Cold air is forced upwards through the bed, partially lifting or suspending the particles, which leads to a speedy freezing. So IQF freezing takes only minutes, preventing the formation of large ice or large ice crystals that can damage the cell membranes, preserving the product shape, color, smell, and also the taste after the defrost. So IQF technology allows for individual unit freezing, enhancing product quality compared to block freezing, and promoting food sustainability by enabling consumers to thaw only needed portion. Rapid freezing in IQF also prevents the formation of large or disruptive ice crystals throughout the product, preserving cell integrity and avoiding damage during the thawing. Let's try to understand the latest trends in IQF or the features of IQF. Double bed system. So instead of single bed, we have double bed, one for the crust freezing and another for the core freezing. We'll understand what is crust freezing and core freezing in coming slides. Then we also have possibility of adjustment of the airflow, bed speed, and vibrations to suit the products. So depending on my product configuration, my airflow, my bed speed, and my vibrations all can be adjusted. Designed for a longer running hours without defrosting. Hygienic design. This is very important for any food industry. Easy access and 100% in stainless steel material. Insulated floor, insulated cabinet walls to maintain the desired temperature, which is between -18 to -35. Evaporator coils are suitable for hot gas defrosting as well as for water defrosting. Let's see what is IQF crust and core freezing. So this is my normal cube. When I'm crust freezing, my entire sides or the walls is crust frozen. And when I go for the core freezing, that is on the second bed, my core freezing is happening. So this is the kind of application that is going to happen. Let's try to understand some parts of the IQF machine. These are the machines which have been manufactured in Neologic. As you can see, we have a double bed system, one on the top on the left-hand side and one on the right-hand side. When you see the other photo, it is also showing the bed, second bed and the first bed. So this is a typical assembly of the IQF inside the cabinet. Then we have what we call as a helicopter agitators. Again, you can see here two beds, one on the top bed, one on the bottom bed. So while my product is moving, the agitator is also moving. It is distributing the product on the entire bed. On the right-hand side, you can see the inside access for maintenance or cleaning for the IQF. On the left-hand side, you can see the conveyor, which is feeding my paneer cubes. I have, although the photo is smaller, maybe in one of the next photos you'll see, we have a vibrator, which is feeding the paneer cubes inside to the IQF. The right-hand side photo you see is typically photo of the fans and underneath of the belt. This is the evaporator coil with the nozzles for cleaning after the session or after the defrosting is taking place. This is the exit of the IQF. From the exit of the IQF, I have another conveyor which is taking it for the multi-weighing machine, and then it will be packed and dispatched ahead. On the right-hand side photo, you can see platform to access in case we have to do some maintenance for the conveyor or other exit parts. Let's try to understand the advantages of IQF. Customization. So as such, we don't have a fixed model. We prepare the machine design based on the customer requirement and to suit their conditions. Hence, each machine will be specifically designed for you. Easy clean. The easy clean design makes all points inside accessible as well as for ease of washing and for ease of sanitizing. Adaptability. Its design has the ability to adapt the needs of the movement by adjusting the efficiency of fluidization and subsequently crusting and final freezing. ASR system, very important. The design is complete with ASR. What is this? ASR is automatic system for removing of the frost from the evaporator during the tunnel work. Thanks to jets of the dry, high pressure air, the aim is to maintain constant ventilation conditions, temperature, heat exchange as much as possible, reducing the defrost stops after several days. And this is also going to increase the performance because the heat transfer is happening very efficiently. So as soon as the crust formation or ice formation is not there on the coils, my heat transfer efficiency remains same. Some of the typical layouts, like I mentioned earlier, the machines are designed based on the customer requirement. So this is a typical layout for a customer, again for paneer freezing. And this is exactly as per drawing what you have seen earlier. This is a paneer IQF installed for a famous brand, Amul. In the forefront, you can see the conveyor which is feeding the pieces of cubes of paneer. Then we have the vibrator which is giving infeed to the IQF. Then we have the entire IQF system. We also have a control panel which is going to control everything from here. This is the inside view of the helicopter agitators which I mentioned earlier. Again, you can see the double belt system. Another beauty of this system is that without going into the system or without opening the freezer door, I can actually observe the entire thing which is happening on the production area by CCTV. And this is my view for the CCTV. So the helicopter agitator which we saw in the earlier slide is now I'm watching through a CCTV. So this is another beauty of this particular system. So this is a typical door, the refrigeration piping. As you can see, the capacity of this IQF is 1,200 kgs per hour of the paneer cubes. Since the videos may not play rightly, we have just put some of the photos. Of course, depending on the request, we can discuss or show in person to the videos of all this to the required customers. Here you can see the paneer after cutting is giving the input to the vibrator. So as I said, these are some of the photos of the typical installation of Paneer IQF. So this session, we are going to see about cheese cooling, how cheese cooling is happening post filling, which is also very important aspect in terms of having its desired shelf life. So first, let's try to understand the processed cheese or its properties. Like most of us know, the main ingredients are cheese, sodium citrate, citric acid, common salt, emulsifier, and class 2 preservatives. It can be in the forms we have been buying cheese famously from various brands in terms of blocks, chiplets, slices, cubes of variety of weights and packing formats. The usual composition is with fat around 24-27%, proteins 19 to 20. Of course, all this can vary from manufacturer to manufacturer. Moisture around 43 to 47%. Added salt around 2 to 2.5%, and permitted natural flavors. Let's try to also understand the processed cheese and its properties. Normally, processed cheese is packaged around 65 to 82 degrees, depending on the manufacturer as well as the typical property of that particular product, and cooled to a specific temperature in slow cooling process. The cheese is then stored at 4 degrees until shipping. So carton dimensions, product mass, filling temperature, product arrangement on the bed, cooling air temperature, cooling air velocities. These are different parameters which are going to determine my cooling time required for effective cooling of the cheese. Again, depending on my cooling time, my capacities, and my SKU sizes, everything can change or everything can vary. So product stimulation, airflow stimulation, airflow distribution, and convective heat transfer coefficient are some of the important factors while designing this cheese cooling system. Let's try to understand what is the earlier ways of cooling the cheese and what is the need of the hour. So post-filling cheese has to undergo slow cooling as a part of its process to achieve desired product properties as well as desired shelf life. This can be for various products like semi-packed or fully packed products. The conventional systems for product linear cooling were the linear tunnels or the blast freezers. So here in the pictures, you can see typical linear tunnels, which were used for conventional cooling or conditioning, what we call. And these are typical linear tunnels. So as I can mention, as you can see on the screen, this is a tunnel for say 2 tons per hour of cooling, and it occupies almost 2.5 to 3 meters by 23 meters in the space in the process hall. So that is how we converted this into a smaller space, compact space. And that is how the spirals came into the picture. Again, the power consumption in the linear tunnels is very high because it requires more power to drive of such a long length. But in spiral cooler, we have the circular, which is leading also for the linear tunnels having higher operational costs. So the development of spirals, as you can see, one of the spirals which is rotating over here, typically with number of layers for different applications. So they were introduced in late 60s, although it has gained popularity in last 2 decades as well. These were alternative solutions for linear tunnels, and these have been widely used nowadays for food as well as for non-food applications. It started with the structure supported systems and then evolved into self-stacking, but the driving mechanism normally remained unchanged, either friction driven, over-driven systems, or as the period evolved, it evolved into direct drive systems. So the direct drive technology was introduced in 2012, which eliminated most of the challenges associated with friction or tension drive, which is slippage or which is more power requirement. So this particular technology of direct drive eliminated all these challenges and made it more efficient and reliable. So the main aspect, what you can see on the technical configuration, spiral being round in nature can have inlet and outlet in n number of degrees. So as you can see in the drawings, some typical layouts are shared over here. So as you can see in the layouts, the tangential entry can be in 90 degrees inlet to outlet. It can be in 180 degrees. It can be in 360 degrees. Of course, we'll see another slide for that. This is another typical drawing of what you can say plan and elevation of typical spiral cooler using air cooling unit to cool products like cheese. So let's try to understand the main features of the spiral cooler. Compactness, as I mentioned, it requires very less space in comparison with the linear tunnel, and it usually arrives partially or fully pre-assembled. Full installation can be done in very few days because it is coming partially or fully pre-assembled. The entire structure is made from stainless steel, so there is no product contamination happening anytime. Bed washing can be added based on the application because some areas there is no requirement because it is cooling by air, no product contamination is happening. But in some cases, we require bed washing. So this can be added based on the customer requirement. Gearbox and motor, as you can see in the moving spiral, it is on the top and it is usually placed outside the cabinet. So it is not exposed to the atmosphere which is happening, which could be cooling, which could be heating, which could be freezing inside the cabinet. And also being outside the cabinet, my accessibility for gearbox maintenance or say adding my oil in the gearbox are far, far better. The central drum is supported between roller bearings. So typically we have top bearing housing and bottom bearing housing. Both are having roller bearings, which can take care of the axial load as well as the tangential load. As I mentioned earlier, flexibility in inlet and outlet orientation, one of the major advantages. Unlike linear tunnel, entry from one side, exit from other side. But here I can have entry from one side and exit from any other side, any degree we want. No belt lubrication is required, and hence there is no product contamination. This is another beauty because the belt is directly engaged in the direct drive technology, which is driving the entire belt. So there is no lubrication required. And of course, low maintenance and spare parts. In fact, some of the spirals have been running 12 years without using much of the spares as required. So let's try to also understand some of the benefits of the spiral. First and foremost, the energy efficiency, because even for a product of say 6 tons per hour, a typical spiral will require maybe around 4 or 4.5 kilowatts of the motor, because it is so perfectly engineered that my 4 kW motor and take entire load of 6 tons as well as the spiral self weight. Leave smaller footprint, like I mentioned, for say 2 tons per hour, I was requiring around say 2.53 meters by 23 meters, 24 meters. So almost 75 meters square meter area. Here I can accommodate the same in say 4 meters by 4 meters, that is 16 square meters or maximum 25 square meters area, because this is, I'm using the vertical space instead of the longitudinal space. Low thermal consumption, because of the compactness of the system and exposure to each other, the thermal consumption here is going to be lesser in comparison with the linear tunnels. Low maintenance, because system is designed in such a way that it can run non-stop continuously without any stoppage or without any maintenance required. Operational cost efficiency, since my electrical consumption as well as my thermal consumption is reduced in comparison with the linear tunnel, I'm having more cost efficient operational cost. And of course, the flexibility in inlet and outlet orientation, which we discussed earlier, which we are also going to see in the coming slide. So this will typically show you that I have top inlet, bottom outlet, but in the same direction, so 180 degrees. Then I have bottom inlet, top outlet, but in 90 degrees. Bottom outlet, bottom inlet, top outlet, again 90 degrees, but in reverse direction. And again, I can have 360 degree bottom inlet, bottom outlet, or bottom top outlet in 360 degrees. So various combinations depending on the site conditions, depending on where my product is coming and where I need to go for the secondary packaging. Based on this, my combination of this inlet outlet orientation can be perfectly finalized. That can be perfectly customized. Like we understood some parts of the IQF, let's try to understand some parts of the spiral. Again, the photos I'm showing is typically used for cheese cooling. On the left-hand side is what we call as the tensioning system. So we have one drive system and we have one tensioning system, and both are aligned with each other in a perfect synchronization. So based on my load, based on my conditions, depending on my torque requirement, depending on my load, my speed or my tensioning in the belt, it's adjusted automatically. This is one of the unique features of our systems. In the middle picture or middle photo, you can see what you can say the air cooling unit, which is producing air at say 2 degrees or 5 degrees and giving the cold air blow on the cheese. On the right hand side, you can see the spiral with number of tiers, and you can see also the yellow cheese packets going for the cooling. So entries from the bottom and going to the top. And depending on my product size, the retention time or the cooling time will change. This is a typical bottom side photo, although we may not be exactly able to see because of the zoomness of that particular photo. We have bottom bearing housing, and we also have dual diameter caps, which are my major, what you can say, components to engage the bed in the starting when the torque is highest. So at the start of the system, the torque is highest. That is where my engagement zone, those dual diameter caps you can see in this particular photo. This is my inlet, this is my outlet of the, what you can say, IQF. So not IQF, cheese cooler. So after the cheese is cooled from say 82 degrees to say 15 degrees, 20 degrees, depending on the customer requirement. Now these are being conveyed with the downsliding conveyor to the secondary packaging. And this is my that conveyor, so which is giving me feeding for the secondary packaging. Let's try to see some of the photos of the spirals in action. Again, a typical spiral with insulated cabinet with 3 different outlets. Like some of the products, like in ice cream, I have cups which require smaller retention time, but I also have family packs which require larger retention time. So depending on my time, I had different outlets. These are photos of the typical spiral cheese cooler, again cooled by air, cold air. This is inside the insulated cabinet, and on the right hand side, you can see the air cooling unit. This is photograph of the, what you can say, spiral cooler HMI, on which all the parameters can be seen, parameters can be monitored, or can be changed as and when required. So on the left hand side, you can see control panel for the spiral cooler. You can also see some of the papers which are SOPs for that particular operator. And on the right hand side, you can see the decline conveyor, which is giving the output of the cooled cheese packet. So this IQF or spiral cooler both have, we discussed about applications in, say, paneer freezing, and we discussed about application in air cooling. But the same machine can be utilized for a number of purposes, and that is what we are going to see in the next slide. So what all IQF can do? Like we saw in the earlier slides, what IQF is more advantageous. So for smaller chunks, smaller pieces like green peas, sweet corn, strawberry, cherries, mango chunks, pineapple chunks, mango cubes or avocado dices, cheese cubes, cheese flakes, or paneer cubes. This is typically everything can be done in the same machine. The capacities will vary. So if I got, say, IQFs for 1.2 tons for say for paneer, then the capacity for green peas, capacity for strawberry, capacity for mango chunks will change, but the machine can be utilized, the same machine can be utilized everywhere. Also for spirals, the same spiral can be used for hot filled sachets or hot filled products. It can be used for cake and bakery items after coming from the oven. It can be also used for namkeen items which are coming out after the fire. It can be used for ice cream. It can be used for cheese, meat, poultry, and different items, or for seafood, hot filled gravies, curries, and some of the non-food applications. So idea of this particular slide is that to understand that the same machine, whether it is my paneer IPF, whether it is my cheese spiral cooler, same machine can be multi-purposely used depending, of course, what are the products produced in that particular factory. So let's take a recap of what we have gone through. In the first session, we understood what is paneer, paneer's properties, and the typical shelf life of paneer, say in ambient temperature or under household refrigeration, and in order to have extended shelf life, how it can be done, and what is the best way of having paneer for extended shelf life, and that is what we understood about IQF, properties of or different advantages of IQF, different components and parts of IQF, and some typical photos of IQF during install. So that what we have seen in the first session. In the second session, we understood the cheese cooling, that is post filling. So when the cheese is filled, say between 65, 70 degrees to 82 degrees in the packet, how it needs to be cooled in a typical, say, time frame required, up to what temperature it should be, say, cooled, and then at what temperature it should be stored in order to have the typical shelf life of the cheese. And for that, we understood that the initial way of linear tunnels is now replaced by spiral air coolers, which are, what are the advantages of spiral cooler, what are different components or machine parts of the spiral cooler, and then some typical photos of the spiral air cooler. So what we can do is, Nikhil, we can move to question and answers.
Yeah, sure. So we have one question from Mr. Praveen Banarkar. He's saying that how the capacity of IQF is calculated.
Yes. So like I mentioned, depending on the prime product you want to get frozen. So in our case, if it is going to be, say, paneer. So my capacity for paneer, like the photos we show, it was typically 1200 kgs per hour. And at the same time, I can have the same IQF used for different capacities for different products. So based on the product configuration, different capacities will be also given to you while we discuss about the IQF. So if your say prime motto or prime requirement for IQF is for green peas, then green peas typical capacity, whatever is requirement will be mentioned. But along with that, what are the different capacities for different products that can be also given to you. So this will be calculated and given to you based on the first prime product and then the secondary products.
Okay, cool. So the session is live on LinkedIn as well, and we have received questions on LinkedIn Live from Mr. Ravi Kumar. So
Okay.
he's asking, if possible, can we know that which are the companies using IQF technologies in Indian dairy industry?
Yes. Who was the person you mentioned?
Mr. Ravi Kumar.
Okay, Mr. Ravi Kumar, so very good question. And we can proudly say that most of the known brands which we are using for the paneer are using the IQF technology. Typically, I would like to mention the Amul name in this particular Amul, Milky Mist. So these are people who are using IQF for the paneer or IQF for the dairy products.
Yes. I request all the audience, all the attendees, they can post their questions in Q&A section, or they can put it in the chat as well. So the next question from Mr. Chirag Mehta, what are the minimum volumes we can do for IQF?
So this will depend on the product, but of course, typically it should start from at least more than 500 kgs per hour or 1 ton per hour, because it doesn't make a commercial sense to actually have a very low product capacity, because the price of say 1 ton per hour and price of 500 kgs per hour is not going to be substantially changing. It may be changing between 5 to 10%, 15% max. So it doesn't make a commercial sense to go on a lower capacities. In fact, if as you go on the higher capacities, your viability or your return on the investment is going to be faster. So typically, as I said, minimum 500 kgs per hour should be there to make a commercial sense. From design perspective or from what you can say, manufacturing perspective, we can design the lower you want, but commercially it will not make a sense.
Okay. So the next question is from Mr. Deepak Pawar. Are there any challenges to be aware of when implementing IQF freezing for paneer production?
Yes. So again, a good question, Mr. Deepak. So the typical challenges is while we are slicing and making the cubes of the paneer, there are very high chances that a lot of particles are sticking to the cubes, or a lot of smaller particles are also passing. So this needs to be avoided, or the challenge needs to be overcome. Of course, for that we give the sieves prior to that. But if you are cutting or if your cube making is perfect, then the lesser challenges will be arriving further.
Okay. The next question is from Mr. GVS Ramarao. What is the impact of texture after IQF compared to the fresh paneer?
So, Mr. Ramarao, all of us know that fresh is fresh, but of course, the IQF technology was developed to have the product after thawing as near to as fresh. So I think that answers your question.
Yeah, basically it is important how we thaw the product. Is also very important when we are discussing about texture. We have to properly thaw the product either by microwave or by dipping it into hot water before using it in a making any preparation of any recipe.
Correct.
Next question is from Mr. Amol Mehtar. Ice crystal forms in IQF or not? I think you have addressed this during the webinar as well.
Yeah. So basically the technology, what we are using in IQF is the crust freezing and core freezing. So that is avoiding all this. So that we have already addressed. Of course, he can see the recording of this webinar on the YouTube, and then he can again understand that.
Sure. Next question is from Mr. Chirag Mehta. How do we clean the IQF system?
Yes. So again, a very good question. Thank you, Mr. Chirag. So like I mentioned, we have a complete CIP system for the IQF, and we have separate spray nozzles for the cleaning of the entire air cooling unit or the cooling coils. So there are two different systems, and depending on the product configuration, depending on after how much time we are doing the defrosting or how much time we are stopping the production, this particular systems can be implemented with the latest technologies.
Yeah. Next question, I would like to take it from LinkedIn Live. We have received the question from Mr. Rathod. How effective to get same structure post thawing? Any technological intervention can help in improving freeze our thaw behavior, as post thawing structure is completely destroyed.
So like Mr. Mahajan was mentioning, how you are doing thawing is very important, and that will change your entire configuration. Again, what is going to be your end use? Based on the thawing process and end use, I think the results can be achieved properly.
Yeah. Next question is from Mr. Ramesh. He's asking like how microbial contamination can be controlled during IQF.
So basically, the temperature itself inside the room is between -32 to -35. Okay. So, and as I mentioned in the earlier slides, that because this is individual quick freezing to smaller particles or smaller chunks, the freezing happens very fast. So my input to output time is very less. So there is very less time for the microbial load development. And also the temperature inside is very on a negative side, that is -32 to -35 degrees centigrade.
Okay. Another question from Mr.
The
Deepak.
entire, sorry.
Yes, sir.
And basically, the entire construction is suitable for cleaning and detergent washing and CIP. The entire build can be cleaned, so we can ensure that there are no pathogenic growths happening when the plant is shut down.
Yes. The next question, another question is from Mr. Deepak Pawar. What are the potential cost saving associated with implementing IQF technology for paneer freezing?
So this cost saving has to be compared with some earlier process. So what we can do, we can ask Mr. Deepak to write down in what comparison he is looking for the cost saving aspect. Of course, from qualitative perspective, the use of IQF is going to be 100% perfect or 100% good. But again, when we say cost comparison or cost competitiveness, we need to understand in which sense he is comparing that. So we will address that separately with Mr. Deepak.
Sure. We can reach out to Mr. Deepak Ji to post this webinar. Another question from Mr. Chirag. Does the moisture percentage get affected post IQF in paneer?
So basically, what we are doing, because we are instantly freezing the paneer cube, there will be a difference in the moisture level after it is thawed, but we are trying to maintain it as the difference as low as possible.
Yeah. Mahajan sir, Gauri sir, would you like to take any more questions?
What is the time? Oh, we have another 6. There is one more question from Arun, whether normal blast freezing decreases the shelf life of paneer, and IQF in that case may play a major role in this.
So the technology of IQF and technology of blast freezing are totally different. Typically for paneer, since we are doing the IQF technology, that is individual freezing of individual cubes, this technology is far superior, because like we mentioned in the earlier slides, if I require say 5 cubes of paneer, I'm just going to remove 5 cubes. I'm not going to remove the entire block, because in the blast freezing, I might be entirely blocking the entire block of that particular paneer cubes.
Yeah, there is one more question from GVS Ramarao about the
Okay.
what is the impact of texture after IQF compared to the fresh paneer?
I think, as I mentioned earlier, this fresh is of course fresh, and we as a human being have a tendency to understand the texture of the fresh paneer. But as I mentioned, with the proper thawing, as well as Mr. Mahajan mentioned, with the proper thawing, you will have as near to as the fresh ones, the texture.
Yeah, I think we are done with the questions. Mostly we have covered. People can, you all can reach out on the email address that is shown on the screen, which is sales@neply.net if you have further questions. Uzarka sir, we can move ahead.
Yes.
Yeah. So to all the attendees, these are some of our previous webinars wherein you can find a recording of all these webinars on our YouTube channel. And then we have upcoming webinars as well.
Yeah.
Which are like new trends in fruits and vegetable processing, wherein we will be covering about single fruit processing versus multi-fruit processing. I'm posting the webinar registration link in the chat box. You can register on the same. Then few upcoming webinars are like new age dairy plant automation, then current trends in food safety and hygienic risk assessment, and beverage and RTD, that is ready to drink, fastest growing sector. So you can register on the webinar link, which is posted in the chat box. So can we have the next slide, please? I would like to thank all the panelists and all the attendees for joining in. It was a very insightful session. I must say, Mr. Ozarkar sir, we very much thank you for the insightful session on paneer freezing and cheese cooling technologies. You all can take the screenshot of this slide. You can reach out on this email address and mobile number. You can also visit our website as well. Post this webinar, you all will be redirected to an appointment link automatically, wherein you can block your appointment, and one of our expert will give you a 1-hour consultation on your queries. And if you have any requirement in future for the machineries, if you are planning for setting up any machineries, you can reach out on these contact details.
And that consultation is entirely free, Nikhil, correct?
Yes, it is entirely free.
And for those whose questions have been not answered, some of the people, like I see Arun has raised his hand, but because of the shortage of time, we are not able to answer you right now. But sir, please reach us, and Nikhil also take Mr. Arun's number or Arun's details.
Sure.
And we'll definitely try to answer his query.
Sure. I have posted the appointment link as well in the chat box. People can click on this and they can book a 60-minute slot with one of our experts. Yeah. Thank you very much, Mr. Gupta, sir. Thank you all the panelists. Thank you all the attendees for joining in.
Thank you.
See you in the next webinar. Thank you all.